So let's talk about data. So a lot of times when we collect data, there's no organization to the data. This is what we refer to as raw data. So what we need to do is organize our data. One way we can organize our data is by creating a frequency distribution which lists each category of data and the number of occurrences for each category of data. Then from there, we can go on to construct a relative frequency distribution. So what is relative frequency? So it is the frequency divided by the sum of all frequency. And we write that in decimal form. So a relative frequency distribution just lists each category of the data with a relative frequency. So the good thing about a relative frequency distribution is it allows you to see the percentage that piece has out of the whole entire data. So, important thing to remember about relative frequency is that the sum of the relative frequencies should always be 1 there. So, let's look at an example. So looking at our data here, we have the number of available cars in a household based on a random sample of 50. So what do we notice about our data? We have the values 0 through 5. So the first step we need to do is identify what type of data we're working with. So we're working with qualitative or quantitative data. Right, we're working with quantitative data, so then we need to identify, are we working with discrete or continuous data? Discrete. Good. So, now let's look at one more thing. So, are we working with discrete that has a few values or discrete with several values? So you'll see that if we're working with quantitative data, we need to determine whether they're discrete or continuous, and then we realize we have 2 cases. It's not broken up by discrete and continuous, but rather discrete with a few values, or we're working with case 2 is discrete with several values or continuous. So let's go back and look at our example. So remember in our example, we're just looking at the values 0 through 5, so that's discrete with a few values. So let's go on. So in the first case, which is the case that we're working with, we have data that's discrete and there are relatively few different values. So the categories of data will just be the observations. So let's go ahead and continue on our example, and then we'll come back with a different example that goes into the case 2 category. So going back to our example, so we have discrete with very few values. So the first thing we do is create a column for our categories. So in this case, it'll just be our data values that we have. So, the values 0 through 5. Now the next thing we'll do is go through, look at our 50 values and create a tally column. So every time we see the number 3, we'll mark the tally 0, etc. So let's create a tally column. So once we've created the tally column, now we can go and add up our tally marks and create a frequency column. So let's do that. So we have 4 zeros, 13 ones, etc. So those 2 things together form what we call a frequency distribution. So just the category column and the frequency column is a frequency distribution. So let's go ahead and calculate the relative frequency. So to do that, we need to know the total number of cars or sample or data values we're working with. So in this case, 50 values. We can also add up the frequencies. They didn't tell us, but we already know that. So let's create a relative frequency column. So to do that, we're going to take each frequency and divide it by the total of all frequencies. So in this case, 50. So 4 divided by 50. And we get the decimal of 0.08. So I could create a relative frequency distribution. So in that case, it would be the number of cars column, and then the relative frequency column, so just the decimal values. I don't need to show all of my work there. So now I can create a histogram. So this is going to look very similar to bar graphs, except for my bars are actually going to touch this time. So let's go ahead and reveal that. So you'll notice across the bottom I have the number of cars. So again, my axis is labeled, my other axis is labeled, so both axes are labeled there. And then the classes are in the middle since I'm dealing with discrete values. So just like the bar graphs, the categories were in the middle. Same thing here. The discrete value is in the middle. And then bars of equal width, so nothing changed there. And then I have indicated what the actual frequency is above the bar just because it's not real clear what those are, not necessary. And then again, I have a title there for my graph, so you want to just make sure that your axes are labeled and there's a title for the graph. In a similar fashion, I could create a relative frequency histogram, so it's going to look very similar. So my relative frequency now is on my vertical axis and my categories are on my horizontal axis, and then I draw bars to represent the relative frequency. So let's go back and look at case 2. So case 2 is if the data are discrete, but there are many different values of the variables, or if the data are continuous. The categories of data are the classes, and they must be created using intervals of numbers. So by intervals of numbers, we just mean a range of numbers. So for example, 0 to 4 is an example. So classes are just categories into which data are grouped. And when a data set consists of a large number of different and discrete values, or when a data set consists of continuous data, we must create classes by using intervals of numbers. So it's necessary there. So in the previous example, we just had the numbers 0 through 5, so not very many values. There wasn't a reason to create an interval of numbers to represent a class. We could just use the individual data values for the class. So a lower class limit of the class is the smallest value within the class, while the upper class limit is the largest value. The class width is the difference between consecutive lower class limits. So we're going to keep that in mind there. So let's look at another example. So again, qualitative or quantitative. So we have quantitative data. So discrete or continuous. So since we're just looking at time in seconds, we're dealing with discrete, and we have several different values. So I've circled the largest and smallest values. So they range from 672 to 738, so we have a wide range. So we need to put them in classes. So in this particular problem, they told you the class width is 10. So how do we determine what to pick for the first class? So we want to look at the smallest value. So in this case, the smallest value is 672. So since that's our smallest value, we're going to go slightly below it, or we can use that value. So I'm going to go slightly below it. So I'm going to start out at 670. So since my class width is 10, I'm going to add 10 to that value, because remember the class width is the difference between two consecutive lower class limits. So I'm going to add 10 to that to get the next lower class limit of the next class. And then same pattern, we can get the rest of those. But how do we know where to stop? Well, this is 738, so I want to go up to include that value. So we want to stop at 730 because the next one would be 740, and we don't have anything in that class, so we're going to stop at 730. And now that I'm done with that, I can go back and write my upper class limits. So how do we know what to stop at? Well, the logical thing here would be 679. But how do we know if it's 679.9, 0.99? So you'll see several different examples. So you just want to look at your data. So notice my data doesn't have decimal points. I'm going to use the same format that my data's in. So in this case, I'm going to use 679. And so I can fill those in, just add down. or you can just think about that being the nines of those. So I would go through again and tally up any of the values that are in that range. So I can create a tally column there, then a frequency column, just like before, and a relative frequency column. So again, the relative frequency should add up to 1. That's always the case. And again, the frequencies there in this case should add up to, let's see, 45. Right? So now we can create a, histogram. So you'll notice in my histogram now that the values, or my classes, the categories here, are at the bars. They're not in the middle of the bars this time, they're the edge. And I'm using my lower class limit, so that's the difference. Histograms, also the bars touch, whereas in a bar graph they didn't touch. So that's the main difference between a bar graph and a histogram. So if we go on over, we can see now if we look at a class with a 5, so I did the same thing with the data there, then my histogram looks quite different. Right? So, what we want to keep in mind here is there's not one correct frequency distribution for a particular set of data, but some of them better represent. So what you want to do is you want to use the distribution that best represents your data. So that pretty much sums up frequency, relative frequency, frequency histograms, and relative frequency histograms.